Everybody loves a great collision, whether it's a tree falling in the forest, or a good old game of billiards. However, many people don't understand the physics behind a collision. In today's video, we will be looking at the physics behind a collision.
Ready?
In this video, a cue ball hits the number 2 billiard ball, which then causes the number 2 ball to move forward. This is a perfect example of linear momentum and the conservation of linear momentum. Linear momentum can be defined as momentum in a 2D plane. Conservation of linear momentum states that linear momentum has constant direction and magnitude unless it's subject to an external force. Let's take a closer look. Let's imagine that the cue ball has a mass of 2 kilograms and a velocity of 2 meters per second. Using the equation for momentum equals mass times velocity, we can find that the cue ball's momentum is 2 kilograms times 2 meters per second, which equals 4 kilograms meters per second. When the balls strike each other, they demonstrate the conservation of linear momentum. This means that the 4 kilograms meters per second of momentum from the cue ball is transferred to the number 2 ball, which now has a momentum of 4 kilograms meters per second. If not for spin, air resistance, and friction, the cue ball would be left in place, while the number 2 ball would roll away. What is also to be considered when a collision occurs is impulse. Impulse is the change in momentum of an object when it hits another. Impulse can be found using the equation impulse equals force times time. In this first experiment, my brother will be hit in the head with an exercise ball. The impulse is greater in this experiment because the time that the ball hits his head is prolonged since it is elastic. Experiment 2, my brother is hit in the head with a hard soccer ball. The impulse is less because the time is much shorter when the ball hits his head.
That was good.
Let's imagine, in this experiment, I weigh 65 kilograms and I hit the bed for 2 seconds total. My impulse then, using the impulse equation, would be 130 newtons. As opposed to this experiment where I'd still weigh 65 kilograms, but I'd hit the trampoline for about 4 seconds total. My impulse then would be 260 newtons. This chart shows the relationship between impulse and momentum, where force equals mass times acceleration, and acceleration is equal to the change in velocity over time. If you multiply the time away from the right side and put it on the left, you get force times time, which is equal to impulse, and mass times the change in velocity, which is just equal to momentum. Now you know all the cool physics behind a crash. Thanks for watching.